Hello and welcome to my YouTube channel. Today in this video we are going to continue with our DMA related projects, and in this video we are going to learn how we can transfer data from memory to peripheral. In the previous video we have seen how to transfer data between memory to memory and peripheral to peripheral. In this video we are going to see how we can transfer data from memory to a peripheral. Let's start the video. So, like in the previous video we have discussed that the DMA actually provides a feature with which we can transfer data or large chunk of data between peripheral to peripheral, memory to peripheral, and memory to memory. So all this data transfer takes place without the intervention of CPU. Therefore, CPU can be used for some more important task when the data transfer is taking place. In this example, we are going to take some data from the memory and we will be passing it to the USART and getting it displayed in the serial monitor. Let us start the coding and see how we can write the program to make data transfer between memory to USART module. So first of all, let me create a new project. For that, I will go to File, New, STM32 project. And then we will have to select the microcontroller board. It will take few seconds to upload the interface. Okay, so here we have to select the board or microcontroller. Like in all the previous examples, I am going to use Nucleo F44 6RE microcontroller board. So here we can select the board, click next and give a name to the project. So let us call it memory to peripheral using DMA. And click finish. So we are not going to initialize all the peripherals in their default mode, therefore we will click no. This will take us to the STM32 CubeMX perspective, where we have to initialize all the peripherals. So here we have the IC. Let me clear all the pinouts. Go to pinout, clear the pinouts, and you will get a warning message. The pinout configuration will be cleared. Would you like to continue anyway? Yes. So we have the raw IC now in our hand and we can configure the IC according to our choice. Now in this case we are going to use only USART for the configuration. So let me just go to the connectivity, USART 2, because it is available in the microcontroller board directly. Done, and then we can configure it to asynchronous mode. And we are not going to change any parameter here. We will keep the baud rate at 115200 bits per second, word length 8 bits, parity none, stop bit. We are not going to change anything here. Let us go to the DMA setting, which is important in this case, and we are going to add USART to TX. Okay, so this will give us all the configuration related data for the USART. And let us check. Here we will keep the mode normal because we are going to fetch the data from the memory only for one time. Therefore, we are not going to use circular mode, and we are going to use memory to get the data from the memory to USART. So just click memory and keep the data with byte by byte. Okay, done. And then just for namesake, we can keep an LED glowing so that the program will not terminate in this case. So let me go for an LED which is onboard LED connected to PA5. Let us configure it GPIO output. Right click on the pin, click enter user label. Let us give it a name LED. Done. And this is all we need. We don't have to make any further changes in the CubeMX. Now we can go to the C perspective to write our code. To generate the C code, we can click on this gear button, device configuration tool, code generation, and this will generate the code and take us to C perspective. So this is our code where we can see all the basic initialization, main function, system clock configuration, and so on. Okay, so let me just collapse it because otherwise this becomes a very long code. So go to folding, collapse all. Okay, so now we can easily change the code without scrolling too much. So first of all, we have to create some variables where we can store the data. So first of all, let me go for define buffer size 20, or you can keep it 30. Okay, it shows how many characters you want to keep in the memory, or how much space you want to allocate for this variable which will store the message. And let us create the buffer variable with the buffer size, and let us generate a message. So I'm going to print a message, hello embedded world. Okay, and for the return of carriage and new line, I will keep /r/n and semicolon. Okay, so this is the data which will be residing in our memory. Now we will have to bring this data from memory to our USART. For that, we can go down, open the main, scroll down, and in the beginning 2, so user code begin 1. Similarly, you can go down, and here we can write the code to transfer data from DMA to from memory to DMA and DMA to peripheral USART. So start DMA transmission from memory to USART. Okay, let us write the code. So for that, there are different approaches. You can go to drivers, all driver src, and here you can see DMA related all the functions which are available in the library. So all DMA init, dinit, start. So here we can see all DMA start. Okay, and now we can go down and we can check. So we are going to use USART. So USART.c, scroll down, and you can see So USART transmit. This is without DMA. And let us check here. USART transmit DMA. So this function we will be using for transmitting the data from memory to USART. So sends the amount of data in DMA mode, okay, when UART parity is not enabled, and it requires 3 parameters. We can see handle of the USART, size of the data, pointer to data buffer, and size of the data. So let me copy this function and paste it here, semicolon. Now we have to populate these parameters. So first will be the handler for H USART2, and then the pointer to the buffer, so TX buffer, and the size of buffer is buffer size. Okay, done. This is all we require to transmit data from memory to USART. And we have created, or we have made a GPIO pin output in which we will keep the LED toggling. So hall underscore GPIO toggle, and here we are going to use LED port and LED pin. So for that, LED control space LED pin. Okay, done. And let us give a small delay, because otherwise we will not be able to see the blinking effect. And let us keep a delay of 500 milliseconds. So after every 500 millisecond, okay, the GPIO pin will keep on toggling, even though this message will be transmitted only once, and after that we will see the LED keep on toggling. So let us compile the project or build the project, and we can see 0 error, 0 warnings. So let me go to debug configuration, and here in the debugger, just check the board is connected or not. So we get the serial number. Remember, auto start local GDB server we have selected here. Go down, enable serial wire viewer if you want to print some data in the serial wire, or the serial wire viewer. Okay, done. Apply debug. Now we have entered the debug perspective. Let us go to live expression and take the variable where we have saved the message. So buffer size, no, live expression. Okay, I have to take TX buffer. So TX buffer is the array which keeps the message to be printed in the UART. So here we can see the buffer, we have the message hello embedded world. Okay, so this message will be transmitted to the UART, and for that let me open the serial monitor console. Go to this icon, console, command shell console, and we have configured the serial port, and let us open that. If you don't know how to create this serial port configuration or remote connections, then please visit my previous video. I have discussed it in a very elaborate way. Click OK. So here it says comet is not connected. So connecting, no. Okay. Let me just cross check what is the issue here. Okay, let us retry. Command shell, and now we can see COM port 8 connected. Now the board is connected for debugging mode, and let us check the TX buffer. We have the data in the memory, which is nothing but a message hello embedded world. And let me open the camera so that you can see the blinking of LED. So right now you can see the LED is not blinking. Okay, onboard LED is not blinking. Now let me open the console. So console is open, and resume the code, and we can see the message hello embedded world has been transferred from the memory, okay, to the USART. And we can also see that the onboard LED is blinking after printing the message. With this, I would like to end the presentation. If you have any suggestions or queries related to this video, then please share your comments and suggestions in the comment section. If you have not subscribed my channel, then I would request you to please subscribe my channel and press the bell icon so that you can get all the notifications as soon as I upload a new video. If you have not liked the video, then please like the video. Thank you and have a nice day.